Now I would like to share with you another example on the system of first order LDE. Find the general solution of the following non-homogeneous system of the first order LDE. This is the question: y1 prime equal to 2y1 minus 4y2 plus 2x exponent plus 2x squared plus 10x. And then y2 prime equal to y1 minus 3y2 plus x squared plus 9x plus 3. So for the first step is to find the YC for the homogeneous system. Okay, y prime equal to ay plus g. So from here, from the question, a is 2, negative 4, 1, negative 3. So this is the metric extract from the equation here. Okay, then y plus g is referred to this. Okay, so 2x squared plus 10x, and then x squared plus 9x plus 3. And then second step is to find the eigenvalue and the eigenvector. Okay, so 2 from the metric, you get 2 minus lambda minus 4, 1 minus 3 minus lambda equal to 0. So 2 minus lambda minus 3 minus lambda minus 4 multiplied with 1 equal to 0. So you get negative 6 minus 2 lambda plus 3 lambda plus lambda squared plus 4 equal to 0. So when you simplify, you get lambda squared plus lambda minus 2 equal to 0. And then factorize it, you get lambda minus 1, lambda plus 2. So lambda equal to 1. So lambda equal, okay, when you factorize, you get lambda minus 1 and lambda plus 2. So you get lambda equal to 1, lambda equal to negative 2. So for lambda equal to negative 2, so 2 minus 2, and then this is negative 4, 1, negative 3 plus 2. So x and y equal to 0 and 0. So 2 plus 2 is 4, so 4x minus 4y equals 0, and next one is the x plus x minus y equal to 0. So you assume the x equal to s, so s minus y equal to 0 and y equal to s. So the eigenvector equal to 1 and 1s. And then for lambda equal to 1, so substitute the lambda equal to 1, so 2 minus 1, and this minus 4, 1 and negative 3 minus 1. So x minus 4y equal to 0 and x minus 4y equal to 0. Okay, this one you simplify from here, okay? Now you assume that the x is equal to s, so s minus 4y equals 0. So y equal to s over 4. So the eigenvector equal to 1 and 1 over s. 1 over 4s. And the next step is to check whether this eigenvector is linearly independent or not. So the first eigenvector I obtain is 1 and 1. And the second is 1 over 4. So 1 over 4 minus 1, you get negative 3 over 4. This is not equal to 0. So this is linearly independent. And step number 4 is the general solution. YCX equal to C1, and then the vector is 1, 1 for the lambda equal to negative 2x. Negative 2. Okay, then C2, and then the eigenvector is 1 and 1 over 4 exponent x for the lambda 1. Okay, so this is the find the YC. So the second part again is find the YP. Okay, find the YP. So first of all, we assume the YP first, but we must know what is the G. The G in the question is 2x squared plus 10x, and then x squared plus 9x plus 3. So this is the G value. So we assume the YP, we can refer to the table. If you refer to the table, here is the polynomials. Just now, the G component has the x squared and the x, right? And also the C, okay, the constant only. Therefore, your YP is the U1x squared plus B1x plus W1. So YP, you assume YP, that one is equal to U1, U2, x squared plus B1, B2, x plus W1, W2. Okay, then you obtain the YP prime. So YP prime from the YP is 2U1, 2U2. Okay, x plus B1, B2. And then the next step is to compare the YP prime with the Y prime. That is AY plus G. So YP prime, so you can copy down from this one. So you get 2U1, 2U2, x plus B1, B2 equal to A from the question is 2, negative 4, 1, negative 3. And then Y. Y is, you have this one. Assume the YP. So this is your Y. Okay. So U1, U2, x squared plus V1, V2, x plus W1, W2. So this is from here. And then plus with the G is 2x squared plus 10x, x squared plus 9x plus 3. Okay, so you can simplify. You multiply in. So you solve this one, multiply with all this. Okay. So 2U1 minus with 4U2. So with metric production for this one and this one. And then U1 minus with 3U2. So I multiply with x squared plus with, for second one, this one, multiply with this one. So your 2V1 minus 4V2, V1 minus 3V2, x. Then plus with 2W1 minus 4W2, W1 minus 3W2. Okay. And then plus with 2x squared plus 10x, and x squared minus 9x plus 3. So now I can sort out the x squared, x, okay, for the left hand side and the right hand side. So for the left hand side, I only have the x, okay, so the coefficient of x. So 2U1, 2U2, x plus B1, B2. For the right hand side, okay, I have the x squared. So I collect all the x squared. Okay, so this part I have the x squared. I have the x squared here. I collect all this here. And then for the x, okay, this one is all the x. Okay, this one also x. So I have plus with 2 v1 minus 4 v2 plus 10 v1 minus 3 v2 plus 9. This is for the x. And then for the x power 0, I have 2 w1 minus 4 w2 w1 minus 3 w2 plus 3. So now I can, by equating the coefficient, so I compare x squared. Okay, so left hand side I don't have anything, so I have 0 and 0. For the right hand side, I have this one. So 2u1 minus 4u2 plus 2, u1 minus 3u2 plus 1. Okay, so now I can say that 2u1 minus 4u2 equal to negative 2. So u1 equal to negative 1 plus 3u2. So this one is equation 1 and second row is equation 2. So I substitute the equation 2 into the equation 1. Okay, so I have 2 negative 1 plus 3u2 minus 4u2 equal to negative 2. Negative 2 plus 6u2 minus 4u2 equal to negative 2. So I have 2u2 equal to 0. Okay. So u2 equal to 0. And u1 I obtain negative 1 plus 3u2 from the equation 2. So you get negative 2 is u2 is 0. So you get the answer is negative 1. Therefore, u1 and u2, so u1 equal to negative 1, u2 equal to 0. Okay. Then I compare for the x. I compare for the x is this one. For the left hand side, I have 2u1, 2u2. Okay. So 2u1, 2u2. The right hand side I have 2v1 minus 4v2 plus 10, v1 minus 3v2 plus 9. So, and from the previous, I obtained the u1 equal to minus 1, u2 equal to 0. So I substitute in this. Okay. And here I bring the 10 to the left. Okay, and I bring the u1 to the right. Okay, so I substitute in the value. So I get this one is negative 2 because u1 is negative 1. Okay, and then equal to 2v1 minus with 4v2. Okay, minus 10. So I bring to the left hand side, I get minus 10. And then for the second row, I have v1, 2u1. And then this is the 9 I bring to the left hand side. That one is the negative 9. u2 you get 0. Okay, v1 minus with 3 v2. So this one is v1 equal to 3 v2 minus 9. So this is equation 3. and then this is equation 4. I substitute the equation 3 into equation 4, so negative 12 equal to 2 3v2 minus 9 minus 4v2 equal to 6v2 minus 18 minus 4v2. So v2 equal to minus 12 plus 18 divided by 2 equal to 3. And then v1 equal to 3v2 minus 9. 3 times 3 minus 9 equal to 0. So therefore v1 equals 0 and v2 equal to 3. Okay, next I want to compare for x power of 0. I have the v1, v2. Okay, if you refer to this one, I have v1 and v2 and also the last part here. So 2w1 minus 4w2 and then v1 minus 3v2 plus 3. So v1 is 0, v2 is 3, so substitute in. And then v2 is 3 equal to w1 minus 3w2 and then plus 3. I bring to the left hand side is minus 3. So 3 minus 3. So from here w1 equal to 3w2. So I assume this is equation number 5 and this is equation number 6. Okay, for equation number 5, substitute into equation number 6. I get 0 equal to 2, 3w2 minus 4w2. And then equal to 2w2. So 6 minus 4, you get 2w2. So equal to 0. So w2 equal to 0 and w1 equal to 3. W2 also equal to 0. So W1 equal to 0, W2 also equal to 0. Therefore, my YP equal to negative 1, 0, x squared plus 0 and 3x. So my general solution, the part number 3, general solution, y equal to yc plus yp. So c1 with the vector is 1, 1. For the lambda equals to negative 2 plus c2. Eigenvector is 1 and 1 over 4 with the lambda equal to 1. And then plus with the yp. Yp is negative x squared and then 3x. So I just cut down for this part. Okay, that's all for the example on the non-homogeneous system of LDE. Hope you understand and enjoy the watching. Thank you very much. If you like my video, please like my YouTube video. Thank you.